Hello everyone, welcome to this discussion. It's a problem under trigonometry where we are required to prove that tan x plus y is the same as tan x plus tan y over 1 minus tan x tan y. So now let's start working on the problem. Here what we're going to do is we're going to work with the left hand side, which is tan x plus y. Okay, so if we look at this, as we know, tan x gives us the quotient of sine over cos, so that is to say this tan x plus y will be the same as this, will simply be the same as sine x plus y over cos x plus y, like this. Now if you look at these two, sine x plus y and cos x plus y, these are the sum angle identities, of which they have ways in how they are expressed. So if you look at sine x plus y, this is the same as sine x cos y plus cos x sine y, and then coming to cos x plus y, what we get is cos x cos y, then we say minus sine x sine y. Okay, now since we know what this is and what the denominator is, we'll then substitute with these two values. Hence we get what the sine x plus y, substitute with sine x cos y plus cos x sine y, like this. Then we divide with cos x cos y minus sine x sine y. Okay, now looking at this that we have and the proof, we're looking at right hand side has two parts on the numerator and two parts on the denominator, and looking at our result so far, we have two parts on the numerator, also two parts on the denominator. Going back to the right hand side, the first part of the denominator has a 1, so mean that even this part we need to make it a 1 since the signs are just the same here. So what do we do to make this one to be equal to 1? What will be required to do is to divide it with itself, and once that happens, it means that what will be done to this part should also apply to the other parts that we have in this expression. So this therefore means that we're going to have the first part of the numerator to be sine x cos y to be divided by cos x cos y, then we say plus the second part cos x sine y also to be divided by cos x cos y, then we'll say over cos x cos y to be divided by itself, then say minus sine x sine y to be divided by cos x cos y. Okay, now if you look at this that we have, first part cos y on top and cos y down will go. Going to have this one to cancel. Coming to the second part, cos x and cos x will go. Then here, this divides this off, it gives us a 1. But when it comes to this part, there's nothing that can be cancelled, but instead we can split this as like this. So we have sin x over cos y separately with sin x cos y multiplying together. With this done, our result ends up being sin x over cos x, plus sin y over cos y. This is to be divided by this one here, gives us a 1 minus, here we have sin x cos y, cos x, to multiply with sin y over cos y. Okay, now sin x over cos x, as you know, sin over cos gives us tan, and since the angle is the same both down and on top, we therefore get tan x here. Then coming to this side, this is also sin over cos, the angle is y, so we get tan y. We divide with 1 minus sin x over cos x is simply tan x, which is multiplying with tan y. Okay, so this therefore means that the left hand side we have, which is tan x plus y, simply gives us this result that we've just obtained. And this therefore means that our proof is done.